Hey folks, I thought I would show you really quick the next step in our matrix math. And it's really simple actually. It's called matrix multiplication and really there's no trick to it. But the problem of course is that if you've never seen it, never done it, it's going to seem totally foreign to you. So let me just show you real quick. No trick to it, okay? When you're multiplying, okay, you have your left matrix. We call this just left and we call this the matrix on the right. The way that you multiply is always your matrix that is on the left. Okay, your operations, you will go in this direction, and then it will multiply these numbers in the down direction. Okay, so that's really simple. Now, your first row multiplies by your first column. Okay, and then your second row does exactly the same thing, which is it multiplies by the same column. So let me just show you real quick. Okay, so in this case, not only that, but they add together. So two operations, okay, multiplying and then adding. Okay, so in this case, we've got A times E, okay, plus B times F. That's for our first sum. Our second one is going to be C times E plus D times F. Now you might be like, oh my God, what a terrible way to multiply. Well, the reason we do this has to do with a lot of much more deep and interesting ways of solving math very, very fast. So right now, since I can't explain it because the theory behind it is pretty complicated, later on though, you will see it actually makes things a lot simpler. Okay. So in this case, of course, we just, all of these numbers add up to a number here and a number here. So let's go beyond theory and let's test in application. Okay, let's just say we've got 1, 2, 3, 4, and then we've got 1, 3. Okay, we follow the same logic. Which is we say 1 times 1 plus 2 times 3, 3 times 1 plus 4 times 3. Okay, and that gives us 6 plus 1 is 7. And that gives us 12 and 3 is 15. Okay, simple. Let's do a second example, just so you'll see one more time. Negative 1, 1, 3, and 2. Okay. And we'll use the same vector. 1 and 3. Okay. Once again, we've got negative 1 times 1. And we've got plus 1. Okay. And then we've got 3 times 1, and we've got plus 2 times 3. You might notice some patterns here, by the way. If you're really astute, you'll notice some of this stuff is happening, and it's going to repeat. You don't need to notice it yet, though, so don't feel bad if you don't notice it. But eventually, you start doing this enough, those patterns are going to explain some of the cool features of it. But if you don't, you know. So here we've got 3 minus 1. That's 2. And we've got 3 times 1. That's 3. And 6. That's 9. Okay? Now let's do one last one. And so, just to show you one of the things you're going to start to discover in this exercise. So this time, what we're going to do is we're going to multiply it by -1, 0, 0, and -1. Same vector, 1 and 3. And look what happens here. This is pretty cool. I like this. Okay. And so here we've got -1 times 1 plus 0 times 3. Okay, and then we've got 0 times 1, okay, minus 1 times 3. Okay, so that zeros and that zeros out. So we've got -1 and -3. Now notice, they're the reverse of each other. As a matter of fact, this matrix here is what we actually call a rotation about the origin. You'll probably want to know that. We're going to see other rotations in the math right now. The important thing is I just want you to see how this works out. Okay, as you noticed, your typical here matrix multiplication, like I said, your left matrix and your right matrix, okay, this one goes horizontal, this one goes vertical, okay, then your next row goes horizontal, and once again you go vertical down the same one, okay. Notice that this means that if we did them backwards, it wouldn't work, but we'll save that for the next lesson. For now, I hope that gets you through. It should. That's all you need really to get through with the next few exercises. Got any questions? Let me know, okay? Okay, take care, guys. Bye.